Okay, I'm going to go through here and um, solve a couple of these conversion problems. And so these will come up on our end of the year test. So make sure you are pretty good at them because they really should be easy points. Now we've got these equations here. We're saying, well, is this v2, does it equal 2ax? And we're trying to prove whether or not it's invalid or not. And then now I think these will be easier than what I put on the Socrative because for one thing, they've given you the equations, which will probably be useful. And I want you to really force yourself to kind of memorize these things. So the trick with it is, if you're not sure, is just set your units, whatever your V2 is, figure out what the units are for V, and then set the units for that on one side, make sure they end up equaling the units on the other side. So we know that V is meters divided by seconds squared. They've given us that up here. So I'm going to write this down, that meters divided by seconds, and then it's squared, so that's m squared over s squared, and then it's equal to acceleration times distance in meters. We can ignore the 2 because the numbers don't have units. And so I have this equal to meters over seconds squared, that's what our acceleration is, times meters, which is what that is right there. So it's equal to meter squared divided by second squared, which is the same as this, so this is valid. All right, and then this next one, I have velocity again, which is going to be meters over seconds, and that is going to be x, which is meters, divided by t, which is time or seconds, so that's obviously valid. Okay. This one is a little bit more complicated. First of all, we have meters, that's what the x is equal, and then velocity, which is meters divided by seconds multiplied by t, which is your seconds. And so this seconds ends up going away. And then we could ignore the 1/2 because again the units or numbers don't have units, and I'm going to multiply that by, or add to that, acceleration, which is meters over seconds squared, and we're going to multiply that by seconds squared. Okay, and again, the seconds goes away. So meters plus meters equals meters. Now this is 2 meters, right? But actually, when you look at this 1/2 right here, it would be 2 meters times 1/2, which means 1 meter. So this is actually valid. So it's meters times meters equals, is a valid entry. Okay, so I guess in this case it was useful to have that number in there. Okay, force is equal to mass times or divided by acceleration. So we have force up here. This is the unit is called newtons. Kilograms times meters divided by seconds squared. And so I think that's going to be obviously our invalid question, plus we've solved all of these. But in this case, we're saying that kilograms times meters divided by seconds squared, that's what we have up here, is equal to mass, which is kilograms, divided by meters divided by seconds squared. Now this is close, but it's not quite there, right? So this is our invalid argument. Okay.